Photography is the scholar's true retina, the astronomer Janssen had said. Our eyes cannot see things that are infinitely big or infinitely large. That's why, as soon as the daguerreotype was invented, scientists adopted this ingenious process which enabled them to acquire knowledge that had previously been somewhat sketchy. Certain photographs can be used for scientific purposes, although they were not necessarily intended as such. It was the case with the heliographic mission in numerous provinces. 5 photographers took part. Their aim was to compile a systematic topographic study of France's landscapes and monuments.
The heliographic mission was the first order made by the French state to photographers. Each photographer had a very precise list of buildings to photograph. They all set off during the summer of 1851 across France. At this time, photography was still very much a makeshift craft. A photographer set off with a very heavy, cumbersome darkroom. He would place his darkroom somewhere because he knew exactly what photograph he wanted. The exposure times were still very long, which enabled him to create effects with the light. In other words, he could take a picture in bright sunlight and then wait for a cloud to go past so as to achieve a strong contrast between the light and shade. This also meant that there was detail in the shadows. It is quite different from the photos we are used to nowadays. In 1851, there was a combination of events that proved very important for photography. There was the heliographic mission and the founding of the first photographic society, which also published the first photographic journal entitled La Lumière, The Light, and which reported what the heliographic mission was up to. It was also the year that Blancart Evrard published his first original prints and put photography in the marketplace. The commission of the historic monuments came at a time when photography perhaps needed state recognition. What is also important to bear in mind is that it was an extraordinary opportunity for the photographers to take so many photos in the space of just a few short months. It was totally new, and for some, it shaped their future careers. Baldus continued to work with state commissions. Lesec continued to take architectural photographs. This period really saw a huge rise in photography.
Despite the quality and the quantity of the prints, it did not lead to the start of a publication. At the same time, photographers were cataloging all the different types of regional physics. In 1873, Louis Figuier, an anthropologist, deemed such an ethnological collection of photographs to be of public interest. These were the days of voyages to distant lands, and photographers developed an interest in ethnology. There was a keen desire to compile a dictionary of types and races. Thanks to Bertillon, photography was used by the police, which set up a department of scientific research and documentation. In 1882, Bertillon began to use anthropometric identification. He based his work on the fact that from the 20th year of a human's life, his bones become almost totally immobile. By taking precise measurements, we can therefore identify repeat offenders. In 1888, he introduced the front and profile photos, which are still in use today. In 1894, he was given the bordereau, or schedule, allegedly written by Captain Dreyfus in the famous Dreyfus affair. He made a monumental mistake in his analysis. However, he then went on to advocate the widespread use of fingerprints, the only form of irrefutable proof. Photos enable photographers like Muybridge to make fundamental discoveries about movement. In Philadelphia, he took over 20,000 photos in 1 year. He photographed sportsmen and men and women engaged in various everyday activities. In 1872, Leland Stanford, ex-governor of California, was talking with Fred McCrellish, another millionaire horse lover, about the movement of a horse's legs when trotting or galloping. McCrellish refused to believe that the horse's 4 hooves could be off the ground at the same time. He hired the services of Muybridge to be sure. The experiment was conducted in 1878 at Palo Alto. Muybridge broke down the movements of a trotting horse by using a battery of 12 cameras triggered by a wire stretched around the track. The work of the Frenchman Étienne Jules Marey were similar to that of Muybridge. He thought that Muybridge's photos were too far apart. He invented a kind of photographic gun capable of taking 12 frames a second. He developed the fixed-plate chronophotograph, which combined a series of successive images. With this partial chronophotography, he obtained the image of the movement thanks to narrow metal bands fixed on the body. Unbeknownst to the two of them, these experiments led to the birth of cinema. Photographers became interested in very brief phenomena such as a small sphere falling into a bowl of milk and the resulting crown shape that is formed. Worthington had to determine the exact moment to trigger the camera so as to obtain this succession of photos. Ernst Mach took the first photos of shock waves caused by the impact of projectiles. Mach considered that aesthetic quality does not detract from the discipline of science, so he wanted the photos to look good too. Guillaume Duchesne de Boulogne concentrated on the human face and its expressions. He published a book in which he studied the various faces produced by different emotions. He described the correlation between the contraction of a muscle and the expression of emotions, such as fear and joy. His photographer was Adrien Tournachon, brother of the famous Nadar. Psychiatrists then became interested in photography too. The photographic department of the Salpêtrière Hospital, set up in 1878 by Professor Charcot, made photography an integral part of the medical practice. Albert Londe favored chronophotography to study the mysterious movements of hysteria. Charcot tried to categorize the passionate facial attitudes of his famous patient, Augustine, in photos that are surprisingly theatrical. Montméjat and Rangade's interest lay in pathology, and they published the Photographic Review of the Hospitals of Paris. Although these photos are pictures of pain, they provided a precise understanding of symptoms and helped to classify different types of illness and disease. The physician William Röntgen discovered X-rays in 1895. He was working in a sealed room when he saw on a fluorescent panel the outline of the bones of his hand. The rays were absorbed, went through the subject, and printed the image on a film. These rays form the basis of modern radiology.
The radiologist must have a double sense of aesthetics. The first is simply to reproduce the elements that he's X-raying in a way that's pleasing to the eye. The second is irrational because his objective is to highlight the points essential to the patient's treatment in every sense of the word: diagnosis, prognosis, evolution, and the therapeutic effects that a lesion might have.
Nowadays, the invisible is photographed with X-rays, but also with scanners which have revolutionized medicine.
Computers have enabled us to obtain images not just in standard one-dimensional radiology, but also images of volume. It's now commonplace to see images in 2 or 3 dimensions, and it's much easier for patients to see what's what. It helps them to understand their illness. When computers became a part of medicine, other methods followed, such as the echography or ultrasound scan. Since ultrasound is harmless, it can be used several times with no risk to the patient, as opposed to X-rays.
Scientific photography was soon used to explore the infinitely small, the microscopic world of cells. In 1837, the Englishman Talbot adapted the solar microscope to photography. Then many devices came along that were compatible with a microscope. Photomicrography was launched. Nowadays, these photos are done by computer and colorized so that the areas under research stand out. The Swede Leonard Nilsson was the first to photograph the miracle of life using a scanning electron microscope or endoscope, a sperm fertilizing an ovule or an embryo in various stages of its development. For the infinitely small or the infinitely large, it's the same process. In 1868, Nadar completed a series of aerial views. To do so, he hired a balloon in which he put all his bulky equipment. To lighten the load, he got in his birthday suit.
The scientific interpretation of aerial photos to observe the Earth took off after the Second World War.
A été vraiment a pris sa pleine expansion.
In the 20s, pilots flying over Peru discovered these giant drawings on the ground. In the late 70s, the photographer Marilyn Bridges took photos of these geoglyphs in Nazca. Aerial photos showed up ancient foundations which were invisible from the ground. This enabled the preservation of such historic sites. Photos taken from the skies have also increased our geographical and geological knowledge of various regions of the world.
We noticed that in natural color photography, the vegetation is green, and in infrared photography it's red. The mineral objects tend to be blue, and everything biotic, that is vegetation, tends to be red.
Geographic information meets the needs of traditional applications such as cartography or map making and agriculture, but it also involves land use programs or environmental protection. Man has always had his head in the stars and his feet firmly on the ground. At the outset of photography, microscopes and telescopes were closely related. We naturally turned to the neighboring planets, the sun and the moon. Draper managed to take the first picture of the moon in 1840 with a half-hour exposure. Before Marianne Weybridge, the astronomer Jules Janssen, keen to record the rare phenomenon of Venus passing in front of the sun, invented a photographic revolver which gave him 48 pictures at regular intervals on a daguerreotype plate. This was the very first chronophotographic analysis of movement. These pictures are easier to understand in a book than through a telescope. Eclipses have always been widely observed. The first solar eclipse to be photographed was on July 18, 1860.
The role of photography in science is fundamental, as it allows us to obtain objective information and not just impressions. In astronomy, it is even more important, as it requires time to have an image that is sufficiently bright, and you can see far better with a photo than with the naked eye. Also, the message transmitted by the light can be reproduced directly as scientific information.
Mankind accomplished a crazy dream, to go to the moon, around the Earth, and into outer space. In 1961, the USA launched a space program to restore their pride after the affront caused by the Russian Sputnik. The astronauts didn't just photograph the moon, the Earth, and their ship. They photographed each other. Hasselblad designed special lenses for use in the extreme light variations in space.
Not because they are easy, but because they are hard.
Liftoff on Apollo 11. Tower clear. We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. The lamp footpads are only depressed in the surface about 1 or 2 inches. I'm going to step off the lamp now. That's one small step for man, one giant leap for mankind. Hippity hippity hopping over hill and dale. Da 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 da.
The conquest of space has continued, going beyond national rivalry and becoming a huge scientific program. In 30 years, space missions have brought us new images of Earth, often of staggering beauty, but always of essential value for meteorologists, geologists, or oceanographers. We now no longer just observe space from the Earth. We send satellites into space to observe it and increase our knowledge.
Satellites have provided us with a perfect knowledge of the surface of the Earth. Spot, a European satellite, can take stereoscopic photos, as its telescopes are mobile and can photograph the same portion of the globe twice from a different angle, enabling us to draw up maps directly by satellite images and aerial photography.
Technology enables us to reproduce photographs of the ground in terms of volume. Satellites measure the light energy that we give off and that telescopes concentrate on banks of detectors. These views of New York indicate the density, the zones of vegetation, the height of the buildings, as well as showing up details on the ground. Probes have enabled us to go nearer the two giant planets of Jupiter and Uranus. They have braved the Jovian magnetosphere, its cloud banks, and permanent cyclones.
Light provides, on the one hand, information about temperature, and on the other hand, information about chemical composition. If you look at the sun, the light is essentially yellow. Therefore, we know that the temperature is about 6,000 degrees. If you look at a star like Sirius, the most beautiful star, its light is blue. So we know that the temperature is around 30,000 degrees. The bluer stars are, the hotter they are. Then there is also the composition, which is studied by a technique known as spectrometry. When you observe the spectrum of an atmosphere or a star, you can see in this spectrum rays which indicate its composition. That's how we know that the sun is mainly made up of hydrogen and helium. Indeed, the word helium comes from the Greek helios, meaning sun. This gas was discovered by spectroscopy in the sun before it was known to exist in the Earth's atmosphere, where it is much rarer.
The Hubble Space Telescope was launched in 1990. It's programmed to last 15 years.
On Earth, we cannot receive ultraviolet light or X-rays from the universe. In orbit around the Earth, though, it is possible. So we have a collection of images that are in fact made up of artificial colors, which correspond to a signal from stars, from objects with a great deal of energy. We also receive radio signals from objects that are not as warm, that have less energy, but which can also tell us a lot.
When two galaxies collide, it's like a clash of the titans. Whatever the impact, the stars which they're composed of are usually not affected, since the galaxies contain, above all, empty space.
When conducting research into planets, we are mainly interested in dust particles, which are of pre-solar origin, and which are formed in thick molecular clouds. These particles are several tenths of a micron in size. We will be able to study them in the space programs of the next century with electron and atomic microscope techniques, which will let us observe infinitely small objects in astronomy too.
In the meantime, researchers have focused their efforts on the planet Mars, an inhospitable world covered with craters.
The information we have about the universe always comes from light, except for when we examine our own solar system. And we'll probably have to wait hundreds of years before we can go beyond our solar system, further out into the galaxy. So the information that comes from light for creatures like us with eyes will always be based on images, provided that these images are usable in scientific terms.
Today, astronauts are replaced by mini-robot probes, which can stand the rarefied atmosphere on Mars, its helium atoms, and any Martians they might come across. In 1997, Mars Pathfinder was dropped onto Mars and began taking photographs. These photos will allow us to reconstitute the planet's volume. This photography does not look much. It comes from another century. Yet it frenetically but precisely accompanies the research and breakthroughs of the 20th century as scientists explore the worlds of the infinitely small and infinitely large, two worlds which look so alike. This photography serves science in its breathtaking discoveries, which leave the humans of the third millennium petrified with metaphysical anguish.